RBS Visit Research Academy welcomes to you in the lecture number 6. So this lecture is about the two-stage approach which involves the partial least square and the ANN, artificial neuron network. So now in the video number 5 we discuss about the how we can analyze the data into the smart PLS, and then we are now again, and then we understood that how we can take the latent variable score and then we can shift that with latent variable score into the SPSS, because ANN we can apply in the SPSS. So that's why there's a combination of the two softwares. One is a smart PLS and another is a SPSS. So let us start our discussion. So, but before this one, my name is Dr. Rainbek Sumro, and I'm working as a professor in the Shabti University. And if you want to contact with me, the following links are available through which you can contact me. So this is our model. In the video lecture number 5, you saw the same model, and now quickly we are applying the PLS algorithm, and in order to get our latent variable score. Because in the lecture number 5, we established the construct liability and validity. And if you have time, you can also watch this the same video for this purpose. And then latent variable, and now here this is the latent variable score. What we have to do is that we have to copy here. Okay, now the same has been copied, and now we can open the SPSS. In the SPSS already I have created some file over there. Just we are pasting our data. So our data is there. Okay, so now some issues are there. Okay, so now we have to remove this one. All these are there. These are numbers. These are not required by us. So we have to remove all these things. Okay, so now these have been deleted. Then we go up, and then again copy all these things from here. Okay, Control X, and then we have to paste into the here countable competence. So now these are two additional. We have to read all these one. Okay, now you look into in the first row, the names of the constructs are there, because we have shifted the data from the smart PLS. So data along with their construct name both have been shifted. So now we remove this construct name, and there the same number I have given already over here in their above bar. So now we have to read this one from here. So clear entity. Okay, so now we have to do some background work. This is the data view, and we have to work on the variable view. So in the variable view, now first of all we have to change the string from the numeric. Okay, and then for rest of them you can copy and you can paste. The status will be changed from the string to the numeric. And then the decimal, we have to increase decimal at least up to 2 point, and copy in the same procedure with this one. And now, and then we have to change some nominal versus scale, and then alignment. I prefer central alignment. Copy and copy it, and then repeat the same procedure with distance. Okay, so now our data is ready now, right now. Okay, so now we can apply the ANN approach on this. This is very simple to apply the ANN approach. Just go into the analyze and then neural networks. If you can neural, so there are the two algorithms. One is a multi-layer perception, and another is a radial basis function. So in the literature, mostly the people have used the multi-layer perception. So that's why we are using this one. Just click it, and you will get this type of window. And then first what data this is the initial video which you will get when you will apply the for the multi-layer perception. So in this one, so first we have to assign the dependent variable. Our dependent variable is the entrepreneurial performance, and the rest of our variables, they are independent variable, and then we have to provide this one to the covariates. And then these are the rescaling covariates are there. You can find out any approach according to your own easiness, and I am following this standardized like the rescaling covariates. And then the next is a partitioning. So here I'm prefer normally the people, some researchers they use a 7:3 or 70:30 ratio, but I'm using the 90 and the 10 ratio. So 90 and 1, then as you change this number trend from 7 to 9, you're looking here that the 9 has been converted into 90% and 1 has been converted into the 10%. So now 90% like the sample we have assigned to the training, and the 10% we assigned to the testing. So if you are unaware about the concept of the training, testing, and the holdout, then please watch my lectures uh, from 1 to 4. You will find the complete information about all these like the partitions. So now here we are giving the two partitions to this one. In the architecture, so we are going to select the Simon architecture. Nothing we have to go for the training, and just in the output is very important. And here we have to select, you can select these one, these are the charts, and this one is the most important. Independent variable importance index. It will create a one table through which you can know which independent variable is important for you. So this is very important to check out. So these, I think that these checkouts are important to select. Rest of things you can leave. Just press OK and you will get this result. So now that's very easy. First of all, we have to look at the case processing sum. This is the n number of the sample size, and here the training total sample size is 384, and the randomly the software has taken 344 for the training, which is a 988%, and the 44, which is 11%, is the testing. Although we provided the 90 and the 10% ratio, but somehow some deviation may be exercised by the software, but almost the thing will be very close to the proportion which you have given to it. Now 90% 10%, so now you're looking at almost the both values are very near to the 90% and 10%. So we have to select 340, and then we have to go. Okay, so for example here, this is the RMC value for the testing and for the training. So now you will then not get the table like this one, but we have to create this table into the Excel. And this is a sensitivity analysis. The sensitivity analysis you have to also create by yourself. The software will not provide the results in this table. So you have to create your own table. How to create? That's very simple. Just go into the Excel. So in the Excel, this is the first one is about the sum of the trends. So we have to provide some sample size. So now this is the template which I have created, and its copy I have placed below the video. You can download it free. This template, and in this one, this is a sample size. What? And this is a sample size for the training. This is a sample for the testing, and this is a total of this one. So now here total I have provided this one. B6 into the B6 C16. So in this way, if you know about the Excel, then I think it's not difficult to remember or to understand this formula. This is a formula which we have applied here. And then therefore, so our sample size, first we need to check sample size. It is a 340 and 44. So we need to change the sample size 340 and the 44. So now the sample should be 384 nowadays. And then we have to go for the okay, this is our graph. In this graph, you're looking here, these are our output are independent variable. This is our dependent variable, and this is our hidden layer. So three level: output layer, input layer, and this is a hidden layer. So hidden layer, we do not know what is being done by the software or what has been done by the software while analyzing the data. Okay, because that's why we call it is a black box. So now the hidden layer function is a Simon. Okay, and then this is the model summary. This is the model summary. This is a sum of square RMC for the testing, and this is RMC for the this is training, and this is for the testing. So now we have to select this value for the training, and then we have to go into the A. So now this is sum of the square for the training. You have to paste it. Okay, and another value you have to take. That's about the RMC value of the testing. Copy it and then just go into and paste here into the testing. So as you will paste, you will find some the values have been changed. Okay, now let me say, although we have provided a value, okay, but this value has been changed, but this value has not been changed because there is a problem error. So now how to remove this one? In this way, you can also learn what of the formula I've used. Okay, so first what I have done is I have provided the equal sign, and then I written I have written the word square root. Click double again. Square root, double click it, and now provide it the range. The range is our 340, and then select it. That means the first like the sample size for training divided by RMSE value. So now and then just press the button, and then you will get the value. This is the RMSE training value for the sum of the error divided by the total sample size. Okay, and this is the value of the testing. So now these two values you have to you have to provide to this one. This is the SSE. So now this is the value. This is sample size. You have to provide sample size for the N. For example, here this is the sample size for N340, and the sample size for the uh, testing. This is 50. So this sample size of 44 you have to write over there. And this is the like the RMSC trend. Okay, this is the sum of the square of the training. So now you have to, this value you have to write down here in this way. And then you have to write down the value of the RMSC 1.84 over here in this one. This is the sample for this is a training for the training, and for the testing purpose you have to follow the same procedure. It's a in and then you have to write down the 13.357. You have to write this value over here. This is the sum of the square of the error, and then if you want to take its RMSE, then you have to write down the this RMSE value here. This is RMC value. Okay, this one. So this is RMC value, and the total sample size value 428, 50, it will become the 478. So now you are looking at 10 times they have done this one. So now we are also required to do the 10 times the same procedure. So the one time we have done, and second time we are again performing. So now you are not required to go into the analyze and just go and find out neural network. No. Now shortcut is available here. Shortcut here, dialog box. Multi-layer perception is again just press OK. So this is the second time. So second time you're looking that somehow our sample size has been changed. Now 341 is our sample size. 341 is our sample size, and then the another is a sample size for the testing is a 43. This is a 43, and total is a 348. Now, okay, so we have to apply the formula over the formula of the sum. So 348. Okay, and then now we have to go for the case processing summary. This is a model summary, and then we have to get the sum of the square value for the training. Wow, we have taken, just come back and then press it here, and then again go back here. Okay, and then take the sum of the square value of the testing, and then just press it here. Okay, so now do, and then copy it here. Now you are getting the value. So now the value of the RMC for the training and the value of the RMC testing now we have received. So now the formula is here. Now you're looking, this is the formula for the square root and the so same formula you can apply. And now because 10 times we have to repeat the sample, it will take time, and unnecessarily it will increase the length of the video. That's why I have developed the same one over here. The same procedure I adopted here, like you are looking the same, almost the same formula I have applied the square root, and then the same formula of square root, and that means the sample size divided by the sum of the square error of the testing or training. So in this way I have received the values of all these one. These are the values RMC testing and training. So now RMC values are there. You can put these values over here for the training, and these are the values you can put here for the testing purpose. So in order to save the time, I have developed this one I have developed this one. So this is our sample size. So you're looking the sample size for each option is equal to 348. This is the mean for the everyone. This is the standard deviation for everyone. So now I have done this one. So it's template. I have the visa provided below the this video. You can download from there. Okay, so now one more important thing. So one more important thing is that how to get this sensitivity analysis. So that's very important, and how to get normalized importance report in average importance. Now that's very easy. Again, for this purpose, we have to select independence variable. Now this is our independent. So now independent variable importance. Now just double click it, and then it will be editable. Now here just click and copy, and then go into the same table like here. So now here this is the latent variable score, and then this is our yeah. So in this way, you can create a one table. The same table I will also have kept below this video for your purpose, and then you can what paste it, and now these are in the like the percentage. You can convert it into the numbers, like the number. Now it has been converted into the number, and then for the next one again, infinite sample size for this one. Again, this is the for the first one. Okay, so that was for the second purpose. Okay, now repeat it, copy it, and then okay, and then again you can follow percentage. You can convert the percentage into the number just by pressing it. So in this way 10 times we have to perform the same procedure. So in order to save that time, already I have created the same table here. So the same table I've created like this one for your understanding. So the process is the same. There is no any difference of the process. So now then I have taken the average. Average, for this average, the formula is here. So for the average, so now formula is there, that where you can put the average C8 to FJ8, and you will get the average for the everything. Just select, and then you can copy the same formula and paste like this one, and then automatically the average for the rest of the videos will be calculated. And then for the normalized importance, now how to get, that's very again easy. Then what the first of all select that the which is the highest importance. So the network has the highest importance. That means 100% is a network is the highest importance among all the independent variables. So now you can make this a benchmark. So if you come here, that how I have done this one, I have done the equal sign, and then L11. Uh, this is our this L, and this is our 11. So now L11, and then what I have done, divided by the dollar sign. Dollar sign is very important, and then the L dollar sign in 11, because this is the our benchmark. So now what, and then you have to take this one. Okay, like this one. So this is the formula. If you apply this formula, you will get a 56%, and then you can repeat the same formula for the rest of the 4 independent variable you will get. Now, from this point of view, it is clear that the network is the most important. That's the third is our entrepreneurial competence is important, and the fourth one is our third one is entrepreneurial skill, and the last one is our third one is a market orientation, and the last one is sales orientation. So now this is a prediction tool. So in the ANN, we are not going to test the hypothesis, but it's a prediction purpose. For the we have predicted that the which independent variable from the importance point of view is very important for us. So now the it is shown in the network among the all the independent variable is a much more important. And then now you can compare the results of these ANN results with the results of the smart PLS. If you now already I put these are the smart PLS results. So from this one, almost the results of the smart PLS are also giving the same thing. For example, the impact of the network on the interval performance is a significant, and now it's 100%. And then impact of the interval competence, impact of the interval skill on this one. So these are three are most important, and while these two, market orientation and the sales orientation, their effect is non-significant. So here you are also getting the effect of these two were non-significant. Although I'm repeating right here that we are not allowed to bring the non-significant like the independent variable for the variables for the ANN approach into the space. Only we have to bring here the significant path. But for our learning purpose, I have brought those two one. So now almost the results of the smart PLS and the results of the ANN both are almost similar. Again, I'm repeating that we use ANN approach for the prediction purpose, and we use the smart PLS for the testing of our hypothesis. So the results are before you, almost the same results are there. Okay. So now how to get the, so now the 10 times we are getting, now this is the average importance. Now average importance, here is our average importance. Okay. And then another thing is our uh, normalized importance. So this is our normalized importance. So these values are normalized importance for each one. And then these are our in these are 10 time we have applied this one. So for the 10 time you are getting the values of all these one. Then we are getting the, so here it is, that is the 100% UV is most important. 100% in our case, the network is most important because its value is a 100%. So in this way you can work in. Now in order to get that, now you have, now 2 times I have applied, but you are required to apply it the 10 times. For each time, just go into the recall recently used dialog box and click select the multiple perception and OK. And then again select the this case processing summary, the sample size 357, and then uh, press this here in the third one, and then press the values of the, these are the sum of square error for the training and sum of square error for the testing in their respective positions. Like this is the sum of square error in this here, and this is the sum of square of the testing over here. And the next thing, important thing is there, that is important, independent variable importance. So now you can double click it and then it will be editable. Then just select and copy, and then you can come here in this sheet, you can paste here. Okay, once these have been pasted, now that means the automatically the formula will take effect, and the values will be changed. So this is overall process of the applying the ANN and the smart PLS. So at the end of this video, I hope you enjoyed this video and you have learned some things about the two-stage approach, which is involving the smart PLS and the ANN in the SPSS. So at the end, I'm again hopeful that you have enjoyed this video a lot and you learned from this video. If it is right, then please subscribe my channel. Please leave your comment and like my videos. Thank you very much for watching this video.